Let's start lesson 3. In this lesson, we are going to introduce a powerful programming paradigm called structured programming. We are going to use the guess game as a running case study for structured programming. Recall the skeleton code of Guess Game version 1. So this is the overall structure. I'm going to explain the code line by line. The first statement is import statement. It imports a package called random. Python is an extensible language. The core language is small, yet you can import many libraries to extend the power of the language. So this import the random package which contains a function called range which generate a random number. The next statement is a assignment statement. It simultaneously assigns value 1 and 100 to variable lower bound and upper bound simultaneously. It's equivalent to two assignment statements, lower assigned to 1, upper assigned to 100. So actually there's no need to have this syntax, but Python want to make it fun, so introduce this kind of shorthand notation for assignment. The next statement called random range function, which is a function defined in the random package, and pass this function with two parameters 1 and 101. Then the function will generate a random number between 1 and 101 minus 1. That means it will generate a number between 1 and 100. This random number will be stored in a variable called magic. For debugging purpose, we print the magic number. In actual program, this should not be printed. We want the user to guess the magic number. The next thing is a loop. In fact, it is a infinite loop. It says that while true, do this block of code. True is a constant. The value cannot evaluate to the false, so the while loop will repeat again and again until the program internally stop it. You notice that the body of the loop is indented. Indentation is compulsory in Python to show the block structure of the program. The first statement inside the loop is to prepare a string, which is a prompt to the user as what should be the range of the data. So the prompt should look like this one. Enter an integer between, say, lower bound 71 to upper bound 89. This prompt can be formed by many substring. For example, enter an integer, another substring generated from the lower bound, another substring generated from upper bound, and so on and so forth. The lower bound is stored into lower variable, upper bound is stored in upper variable. Here all the substring need to combine together to form a longer string using the plus operator. So the plus operator is overloaded here, and we use it as a string concatenation operator. In order to use it consistently, everything need to convert into string. So the lower, which is the number, need to convert into a string using the str conversion function. Str is a conversion function, convert an object to a string value. Next is to get the user input. So the function we use is input function. The parameter is a plum. So input plum will print the plum to the screen and wait for the user to enter one line of string. Note that input return a string, not a number. So when you enter 70, it's a string 70, not 70. Therefore, this string need to convert into a number using int, which converts a string into a integer value and store the integer value into this variable called guess. The next statement is a nested if statement. So it compares the user guess with the magic number to see whether the guess is less than the magic number, greater than the magic number, and adjusts the lower bound, upper bound accordingly. If the user get the magic number correctly, the system will print bingo and execute the break. This break is a statement telling the system to get out of the inner loop. The else if keyword stands for else if. In other language, this kind of nested if statement will be written this way. We call it the ladder if structure. So ladder if structure is two branch if statement. So if guess less than magic is true, execute this one. Otherwise, execute the other part. And the other part happen to be another if statement. And so on and so forth. So you will see that the ladder if structure use a lot of indentation. And if, in this case, we got only 3 branch. So it look fine. If you imagine you got a 10th nested condition. So the ladder if structure will have indentations that easily go out of screen. So Python as a fun language introduce this keyword else if, and with this keyword you can avoid the excessive indentation in your program. By now you should have finished your guess game version 1. You should also notice that the guess game version 1 is not very user friendly. When you enter a number, the system didn't tell you whether the number is too small or too large. So here you can display a message by adding print statement, such as print too small, print too large at appropriate place. By now you should have finished guess game version 2. If you let other user praise the game, you will notice that sometimes the user will enter stupid input. For example, when asked the user to enter something in between 6 to 87, the user maybe enter 90. In this case, you want to tell the user that the input is meaningless. Here, the program just scold the user, stupid, your input is way too big. Of course, in actual program, you should not do it. How to achieve this thing? We can do a form of data validation before we use the data. So once we get the user data, we can perform so-called data validation. If the guess greater than upper, which should not be, in this case, we can score the user. And similarly, if the guess is less than the lower bound, we should also score the user. And after that, we use a keyword continue to skip the decision and go into next iteration again. So essentially, just ignore this stupid input. We have used the break and continue keyword to control the flow of execution of a loop. The break keyword forces the execution to get out of the loop and continue outside the loop. The continue keyword forces the loop to go to next iteration and skip the remaining part of the body and go to next iteration. So break and continue are useful tool in controlling the execution of a loop. The guess game can be enhanced to allow the user to play the game again after you get the magic number correctly. This can be done by adding an outer loop to the current code in version 3. So to do that, we select the code, accept the import random. Once you choose this portion, you can click the format menu and choose indent. The system will indent the chosen part one tap to the right, and it will become part of the outer loop. Once we indented the code, it makes room for us to insert a outer loop. Here we are going to use our familiar infinite loop structure. Well, true. Well, in this way you allow the user to repeat the guess game again and again. However, the user cannot end the program gracefully. The user can end the program by entering Ctrl C. However, the screen will look ugly. The solution is ask the user to decide whether to end the game after bingo. So after bingo, we get out of the while loop. We ask user, do you want to end the game? And telling the user expected answer is Y or end. And if user input is Y, then we break. This break will break the outer loop and end the program. Otherwise, it will loop again. So here is a sample run of the guess game version 4. So the system will generate a magic number. Wow. For debugging purpose, we can see it 72. And ask us to enter integer 1 to 100, and if the user enter 200, you get score. And the system will skip to next iteration, ask the guess again. And so if you enter 80, it's too large. Enter 70 will be too small because 70 is less than 72. If you enter 72, it will say bingo. Then you go to, before you go to outer loop again, repeat the game again, it asks the user, do you want to end the game or not? That's we say end, indicate no. So the system will generate another magic number and ask the user to guess it again. So assume that we guess it correctly. Next time the system will ask us whether to end the game or not. This time we say yes, and we are going to end the program here. The guess game that we develop make use of structured programming. Structured programming is a programming paradigm that aims to get rid of spaghetti code. Spaghetti codes mean unreadable code, where the code structure is very messy. We don't know where the code start, where the code end, because spaghetti code make use of, we call it go-to statement. The code will jump here and jump there, hard to predict. On the other hand, structured programming encourage using block structure to show the flow of the program. The overall structured programming allows us to write programs that are well structured and easy to understand, and therefore the quality of the code will be better. Structured programming language support the following control flow structure. First, sequential structure. So the runtime system will execute the code one by one in the order of the program. Next is a selection or decision. So typically we use nested if structure, ladder if structure, or another called switch statement to control the decision making. Lastly, we got the loop structure. We control the repetition of the program. Any programming language that support these three structure are called structured programming language. Modern programming languages are all structured programming language. So according to the program outline, the first part is to read score from keyboard. Well, we can reuse the code from guess game. So give a prompt, get a user input as a string, convert the string into integer, and store it into a variable called score. Next, we need to convert the score to grade. Here, we can use nested if or ladder if structure. Okay, score is greater or equal to 69.5 or 70, doesn't matter. So you get an A. Otherwise, if the score is more than 60, you get a B, and so on and so forth. So this should cover all the case. This is the end of lesson 3. Thank you for your participation.